Hello, my fabulous chemistry minions. Now we are going to get into the bulk of organic chemistry. We've gotten through our learning targets, we've gotten through our vocab, and today we can describe the properties of covalent bonds. This is the basic carbon chemistry piece. Okay? Carbon forms 4 covalent bonds. We need to know this. So carbon is so special because it forms 4 bonds. That is an actual testable question. I've seen those Regents questions on the finals. The possibilities include, now this is the only time I'm going to talk about this. Unfortunately, it is testable, so I'm not going to dwell on it very much, I promise. Carbon chains called aliphatics, okay? Long carbon chains. They also form rings, though, called aromatics. And there's also branches. So that's a chain with a side chain. There are non-functional carbon groups like hydrogen or bromine or nitrogen that come in. So, and hydrogen was the wrong word there. All allowing for hundreds of billions of possibilities, all because carbon makes specially 4 bonds. The rings are something we're not going to talk a lot about. They're in that picture right there. And I'll show you a picture of what we call a buckyball, which is some new carbon chemistry that's going on. And now we're even getting into sheets of plain carbon where it's 1 atom wide, thick, and you can get a sheet of carbon, and that is like turning into organic electronics, things that go in new smartphones and make them even smaller and thinner. So the technology is still evolving, and it's kind of cool. There's rules for carbon chemistry, so let's get into that. First rule, every time we draw these things, every carbon must have 4 bonds, and you need to be able to count these things and make sure it has 4 bonds or there is a problem. Carbon is always the central atom or the backbone. We learned this back in bonding when we did covalence. So this is true still. Carbon will always be our backbone. All covalent bonding rules apply. So, and that means, low melting point, low boiling points, generally, could be polar or non-polar, all those things that we learned back in bonding. Okay. This system that we're about to learn is very robust. We can draw the molecule from the name. We can come up with the name from the molecule. The prefixes and the number tells us the number of carbons. The root tells us ane, ene, or ine, and all deviations from the basic alkane structure is noted in some way to let us know where's what. Okay. And it's that part of this unit that there's no deviations from. There's no exceptions. These rules are very straightforward. You learn the rules and apply the rules, and you're going to do smashingly. If you fight the rules and you reject the rules, then things aren't going to go so well, and you can't go back and forth. So I need you to kind of make up your mind on that and get on with it. Okay, properties of organic compounds. Again, covalent bonding. They're mostly water soluble, but not all of them. They have low conductivity, low melting points, low boiling points. They have slow reaction rate, which makes the reactions more easily controlled sometimes. All right. And then we have empirical and molecular structural formula. So structural formula looks like this. So there's not a lot of room for you to write too much, so I don't need necessarily to draw that. But so we'll write it. This is the number of atoms with the number of bonds in the arrangement. You could say that it's the most information, that structural formula. You're going to have to draw them, and that's the lab. You're going to have to draw them in little spaces in your practice packet all over the place. So we're going to be doing a lot of drawing these structures from the name. Okay? And if I can do one, then I can do the other. So I can come up with a molecular formula very easily from the structure. Just count them up. Okay, this is how many carbons, how many hydrogens, how many of everything that's there. So this is just simply the number of atoms. And there aren't too many rules. We generally do the carbon first, right? But there aren't too many rules. If you get the order a little bit mixed up, but they're all there, that's good. There's some rules that you're going to find that I use for functional groups like alcohols. I always want there to be an OH because I know OH is a functional group for alcohols, not just bases. Okay, when it's bonded to a metal, it's a base. When it's bonded to these non-metals, it's an alcohol. Difference. Then the condensed formula is kind of cute. That's this one up top. And the condensed formula shows me how many carbons and hydrogens. But notice I don't just put, 1, 2, 3, 4, 5. I don't just say C6. I space them out. And this gives me a lot more information about where these things are. So that helps. So gives me the number of atoms and their arrangement. Condensed formulas are not so much testable, but I want you to know that they exist, and sometimes they're better to use because I get so much more information from them. Okay, micro and macromolecules, carbon create. We are carbon-based creatures. So here's a picture of DNA. If you need to come up with a way to remember, or a picture or something that you can write there about DNA that you know, write that. These are all kinds of enzymes and proteins. So these large macromolecules can be made. We can make polymerization. We can make these things that are enormous as far as the numbers of carbons that are there, and give them very, very specific shapes and functions, like proteins and enzymes. Okay, all words you've heard of before. So there's some notes there about this, of those words at least: proteins, enzymes, that kind of stuff. These are the things we can make with carbon. Okay, and here's a picture of the buckyball, and I actually did a nice long paper during my advisement part of my chemistry career back when I was in college about these particular things, where all the blue dots there are carbons, and it actually makes a full sphere. And I can put something in the sphere. I can make small attachments to the outside of the sphere if I can get one of those carbons to move. But once I form these things, they're very, very steady, because look at how strong they look. And they last a nice, good, long time. So this is a cool new technology that we've come up with. And the nickname is buckyballs for these. Okay, so maybe something about carbons forms rings. Notice you see the ring, the six-sided ring, and now this is a five-sided ring, and a six-sided ring, and a six-sided ring, and a six-sided ring. They can all fit together, and so that's kind of neat. And then rings are something that I'm not going to spend a lot of time on throughout the unit, but I need you to know that they exist, and that carbon can make rings if by chance you see a multiple choice question like that in the near future. Okay. And other than that, that's about it. So, and then that's it for this first one. So this was just kind of an overarching theme video. We're going to get into the specifics next one about how we start drawing and naming. Cool. See you. Press the button if I can find it.